Today we're going to be going over some quick facts about exponent rules. So the first thing that we have to start with is just what is an exponent and what does it mean. So if I have something that's like x to the a, here this a is my exponent and this x is my base. And exponents are just telling you to do repeated multiplication. So what that means is if I have x raised to an exponent a, I'm multiplying x by itself a times. So an example of that would be something like 5 cubed. That means I'm multiplying by 5 3 times. So 5 times 5 times 5, which will end up giving me 125. So we're going to use that basic fact to go through these different rules. The first rule that we have is the product rule. So if I am multiplying by some number with the same base, but it's x times x, and they're each raised to different exponents, so let's say a and b. That means I'm multiplying by x a times, and then I'm multiplying by x b times, which is really like multiplying by x a plus b times. So there's our rule, and let's do a few examples. So first, let's start with a basic one. Let's start with 5 squared times 5 to the 6th. If I ever forget the product rule, what I can do is write it out, knowing this fact up here, what I know about exponents. So this is really 5 times itself twice, right? That's 5 squared, times 5 times itself 6 times. And you can see why we use exponents now, because we don't really want to write this out that many times. So now I ask, how many times if I'm multiplying by 5? If I count up all of those, it's 8. Now, if I want to use our shortcut, our rule, then I just say, well, that's equal to 5 to the 2 plus 6, which is 5 to the 8th. Let's try one more. So let's try y to the 4th times y cubed times y. Now this is really, there's a hidden 1 right here. So there's really a 1, and now we're just multiplying 3 times, so we'll do y to the 4 plus 3 plus 1, which will give us y to the 8th. Now the last thing that you might see is something with 2 different bases or even more. So say we have something that says like 7x squared y cubed times 2 x to the 4th y to the 5th. Now, what's really nice about multiplication is we can always reorder things. So remember, between all of these, there's really a multiplication sign. So now I can rewrite this so I have things that are similar next to each other. So like 7 times 2 times x squared times x to the 4th times y cubed times y to the 5th. Now, the mistake that people always make when they're so used to now doing these exponent rules is they forget basic multiplication. So right here, this 7 times 2, there's no exponents, there's nothing really involved. It's just what's 7 times 2, and that's 14. A lot of times people are so used to this product rule up here that people end up adding. So just remember your basic rules. Now, x squared times x to the 4th is x to the 2 plus 4, which is 6. Y cubed times y to the 5th is y to the 3 plus 5, which is, let's see, 6, y to the 8th. Now, next up, we have the quotient rule. So remember, quotient means division. So here's our rule. If we have x to the a divided by x to the b, we actually end up with something that looks like x to the a minus b. So what you do here is you're going to, if you're dividing, you're really subtracting. So let's try an example. Let's say we have 6 to the 13th divided by 6 squared. Now, if we ever forget our rule, we can write this out. So this is where it becomes a pain. So 6, 7, 8, 9, 10, 11, 12, 13. So I multiplied by 6 13 times, and now I multiply by 6 twice. When I do that, notice I can end up canceling. So I can cancel here and here, and I can cancel here and here. And now how many times am I multiplying by 6? I'm only multiplying by 11 times. So this is 6 to the 11th. If I want to do this with the shortcut, I just do, this is 6 to the 13th minus 2, which is 6 to the 11th. Next up, we have power of a power. So what this looks like is if we have something like x to the a raised to the b. And so what this becomes is x to the a times b. So let's see an example. Let's say we have x squared to the 5th. Think of this x squared as like a little lump all in itself. And we're doing this 5 times. So this is like x squared times x squared times x squared times x squared times x squared. Now, I know x squared is really x times x. So this is x times 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 x. So now how many times am I multiplying by x? It's really 10 times. So this is x to the 10th. If I wanted to use the shortcut, I could just say this is x to the 2 times 5, which is x to the 10th. So notice our rules make our lives a lot easier. Next up, we have power to a power. So this is something that looks like, I have the wrong one. So power, let's fix this real quick, of a product. So remember, product means to multiply. So what I'm going to do here is say I have something that looks like x times y to the a. What I do here is I distribute this exponent to everything inside. So I say this is x to the a times y to the a. And now x and y are different bases, so I can't combine them. The reason this gets tricky, let's try an easy one first. So let's say I have 5 times 7 to the 12th. This is just 5 to the 12th times 7 to the 12th. If I have something that looks like this, let's say 6x cubed squared. What happens here is people remember to give this to the 3, so they remember this x to the 6, but they forget that the 6 also needs to have the exponent. So this is 6 squared x to the 6. So that's like the biggest mistake people make for power of a product. Next up, we have power of a quotient. This is pretty similar. So here, if I have x over y to the a, I distribute the a to everything. So this becomes x to the a over y to the a. So again, this is pretty simple, but let's try an example that's a little bit trickier. So let's say we have 2a to the 5th divided by b to the 7th raised to the 3rd power. Now, I need to give the 3, this exponent, to every single term. So I need to give it to the 2, to the a, and to the 7th, and I multiply. So this becomes 2 cubed, a to the 5 times 3, over b to the 7 times 3. So this becomes 2 cubed a to the 15th all over b to the 21st. Next up, we have 0 exponents. So this one is a little bit weird. For the 0 exponent, we have a to the 0 is equal to 1. So that means anytime we're working with a problem, that if we see an x to the 0, it's just 1. So x to the 0 is 1. There's a nice easy example. Here's another one. Let's say we have negative 3x plus 7 to the 0 power. Again, that's just 1. So anything to the 0 power, no matter what it is just 1. Next up, we have negative exponents. So negative exponents look like something like this. X to the negative a. Now, negative exponents don't really mean negative numbers. So what the negative exponent really means is division. So this is telling you divide by x a times. So what this really turns into is 1 over x to the a. So let's see an example. Let's start with an easy one. 5 to the negative 3. A lot of people just like to say this is negative 5 cubed or something similar to that. What this is really telling you is we're going to divide by 5 3 times. So we're going to take this as 1 over 5 times 5 times 5, which is just 1 over 5 cubed. Let's do 2 more examples. So let's do an easy one first. Let's say we have x to the negative 7th. We don't like to leave negative exponents. We like to turn them positive. You can turn it positive by moving it down into the denominator. So this becomes 1 over x to the 7th. Now here's one more that's a little bit tricky. Let's say we have 1 over y to the negative 5th. What we can do is move something up. So if we bump it up or down, it changes it to a positive exponent. So in this case, we bump it up to make it positive, and it changes to y to the 5th. So that means like if we have any number over some other number, if we bump it up or down one place, it changes it from positive to negative or negative to positive. Last up is rational exponents. So I just wanted to have all of these notes together. We're going to learn about this in a few videos. But if we have the bth root of x to the a, that is the same thing as x to the a divided by b. So those are our basic rules. So again, let's just write these here. So, product rule says if you multiply two numbers with the same base, then what we do is add the exponents. Quotient rule says if you divide, subtract the exponents. If you raise a power to a power, multiply the exponents. If you raise a power of a product, so if you are multiplying two numbers, raise each number to the exponent. Same for power of a quotient. If we have a division problem, we raise each number to the exponent. Then we had our 0 exponent, which really means any number to the 0 power is 1. And last up, we had our negative exponents. So if you change from numerator to denominator or back the other way, exponent changes signs. So it moves from positive to negative. So there are our basic exponent rules.